This video is proudly sponsored by whatisZS.com. Okay folks, this is actually the little project I've just done in tinkercad for the sensor alarm, i.e. with the modifications and everything. So now that I know that it looked good in Cura, I'm actually printing it. So I left it as one STL. I thought, well, it's only two small components, it's only going to take an hour, so I left it as one small STL. I am going to actually save it as two for the actual what do I call it? Thingiverse. So I'll upload it as a new version of the, and I call it the piezo alarmed sensor alarm. Yeah, so I'll put a link to it in the video when I get the link and all that set up in the thing, so that if you want to print my version with a little space, and all it is, it's just a little gap. It's a little box to put a small piezo alarm in. You run it in 12 volt power, 12 volt power to it, or whatever the piezo runs off, and you just find that on the circuit board, run it up to the thing, and or you can stick a battery on it. Yeah, attach a battery to it and bloody do that. There, that's one way of doing it. But yeah, no, the best way is to actually run power to it. So we'll print it up and everything, and like I did print it before, as I said, and it sort of failed because what I did is I didn't think about the lid very much. And I put the lid on the wrong side. I tried to actually move the lid and just switch it over like that, but no, it didn't work, so that's why I had to do it. It's just I wasn't paying attention when I was modifying the first one, and yeah, so that one worked, but unfortunately the lid didn't fit it, so I had to revamp it and redo it again. And yeah, it's all part and parcel of the stuff, but yeah, you can make mistakes, and it's not hard to make a mistake with any program. So those of you out there that like it, enjoy this video. It's just going to be the printer and noises of me talking or grunting or whatever in the background. No, I'll still talk to you. But no, it's sort of, there's lots of things that you can actually do. And being a student, right, it helps being a student, because if you're a student, why has that disappeared? If you are a student, you get access to softwares. Like because I'm doing some stuff in 3D design, and I've got to learn how to build cities, so I thought, well, okay, I'll have a look at their architectural software so I can sort of get an idea on how to build cities. Because I'm actually doing animation this year at college. Been at college 27 years this year, so it's a long time. But yeah, no, one good thing about being a student, Autodesk does give you the opportunity to learn their software. And I strongly recommend, if you are a student and you need these sort of packages, go directly to Autodesk and download them. You go to Autodesk, type in Autodesk Student, and do that in Google. It'll take you straight to the education free software that you can use. You get a limited license, and it is only for a period of time, generally only while you're studying. I got 2 years, and I've 2 years to go on this course, so yeah, and I've just downloaded the latest versions of the software I know that I am going to need for this year. So and yeah, so it's a brilliant little program, guys. It's sort of like I've used Fusion 360 once or twice. I'm a bit iffy about it. AutoCAD mechanical I've used AutoCAD electrical, and now I'm going to try the architectural. I've used Inventor a bit more than Fusion, but I'm still learning both those programs. And you can learn anything with a bit of time and a bit of patience, and it does help that you have companies like Autodesk out there doing this for students, See, the reason why Autodesk do it is because they know that students are going to come along and buy their software. Yet Adobe make students, because they know students have got to study it, so they charge a fortune for it, and it's a limited license for 12 months, and then you've got to pay full fee. And if you're studying for a few years like me, yeah, that's a bit of a thing. You've got to pay $400 a year after that, and as a student, students can't afford that. Where Autodesk actually lets you use their software whilst you're a student. So, and it's helped me do what I've got to do. AutoCAD Mechanical helped me actually design my invention while I was going to college. And so there's many different programs. I plug Autodesk to everybody. Autodesk doesn't even have to pay me. I think because of what they do for students is absolutely brilliant. And you've got to know to tell them where you go to college and everything so they can check. It's not hard with me. It's I just put in the thing, what I'm studying, and bang, that's it. And it's easy. It's sort of, when I did mechanical engineering, as I said, I used AutoCAD Mechanical. And even I did all the designs for my patent using AutoCAD Mechanical student version. And I didn't think I'd need to get my patent, but yeah, so it's sort of, there's a lot you can actually do and learn, because you never stop learning, and that's the great thing about life. You never stop learning, and those that stop learning give up on life, I think. And it's sort of like, I was told 30 years ago I'd be in a wheelchair, and you'll be in a couple of years and you won't be able to walk. It's getting worse, it's getting worse. And I fought that off all this time. Like, it's hard, trust me, it's very hard. But it's sort of, I've battled that wheelchair away. Just, I've done so many different things over the years, and to stave off the chance of going in the wheelchair, I've seen so many doctors, this doctor, that doctor, and getting new treatments, getting new physios, and just learning how to do it, and doing basic exercises at home just to stave off that wheelchair. And it's hard, but yeah, you do it. And but as a student, it's sort of, I found that it keeps my mind active, so I go to college, and I've learnt quite a lot. I've done my diploma in art, and they never gave it to me because I refused to do life drawing due to my Christian values. And the thing is, it's sort of, they let the Muslims off with it, but they wouldn't let Christians off with it. But yeah, no, so it's sort of, I've just studied at TAFE and just learnt what I need to know. And I need to learn animation from one of my films, and so I'm studying animation. Studied games last year and everything, so yeah, it's sort of thing, but there's not many companies like Autodesk. There really is not. It's they're a brilliant company. And because they do it, like there was a stage there when I wasn't studying and I had to actually buy Autodesk because I wanted the latest version, so I went out and actually bought it. And but now I'm back studying again and studying something that actually needs it. Yeah, they give me access to the new versions of the software, which is great. So yeah, if you're a student and you're studying these subjects like mechanical engineering, electrical engineering, civil engineering, architecture, design, they have the software packages to suit you. So honestly, as I said, this is not a paid ad. This is because Autodesk lets me have the software for free, and whilst I'm a student and studying, which is great, and I think they're absolutely brilliant. And it is absolutely incredible software. It's hard to learn, don't get me wrong. Some of it's hard to learn. I remember when I first started learning Maya, holy crap, yeah, mackerel, it was hard. Really was hard to actually learn it. But they've got that other one program here, like tinkercad. And tinkercad's, yeah, like I made a few little mistakes while I was doing it, but I was able to come back and check, because as what I showed you and everything, by going and checking with different things, that you don't have any dramas. And as you can see there's the design there, and it was just a simple mistake that I made. That's all it was. I forgot to flip it over, and I just kept on building onto it, and I built onto the wrong side. But now it fits together, it works, and yeah, and all I had to do was flip it and move it. That was it. So it's not a bad little program. This is something that you access online, by the way. Tinkercad. You do need to sign up to Autodesk, and they give you, yeah, Autodesk. This version of Tinkercad, which allows you, because see, the pink and the green were the other chap's redesign. Someone else had designed it originally. I don't even know who that chap was, but I got it off, where is it? Is this it? Yeah, I got it off, I can't even find it. Yeah, somebody. No. Yeah, it's in there somewhere. It's one of the files in there. And I'm learning how to make robots walk by just these little walking robots. The thing is, it's sort of, there's a lot of stuff out there. I'm actually building this 3D printer. Sorry, 3D printer. I'm 3D printing this CNC. So far I've got the sides built, I've got that piece built, and there's another piece that you can't see because it's hidden somewhere in the design somewhere. And yeah, so I'm slowly getting everything built, and yeah, so eventually I'll have that finished as well. But yeah, it's amazing what you can do with the 3D printer. It really is. 3D printing is the way of the future, and those of you that don't own 3D printers, man, you're silly. They see, but you don't just print silly little articles. You actually can print a 3D CNC. And I'm printing that CNC so that way I can carve the bigger one and make the bigger one, which is, no, not that one, that's still not it, it's still this one. Well, there is a bigger version to this one. This is the Root 2, there is a Root 3. I'm building the Root 3 Lite, which is similar to this one. And this is just the next. This was pretty much the second incarnation, but Root 3 is the incarnation of the big one, and coming back to this size though. But I need this to carve out the sidewalls for the big one, but I'm not actually making mine that size. I'm making mine much larger, but it still can only use this spindle. That's the problem. Because it only has a 52mm spindle ability. So what I'm doing is I'm rigging the big one to take a Makita router. So on the Makita router I can put bigger bits, I can chunk straight into aluminium using mills and things like that because of the bigger spindle, faster speeds, and yeah, but I need to make stronger parts. But even, I would even be confident enough to print them if my printer base was big enough. So there's a lot you can do with 3D printing, folks, and as I said, there's software that you can get, good companies like Adobe. You've got programs out there that do help you out. You've got this like Microsoft IDE, which is Arduino for Arduino. You can go into Thingiverse and you can build all these stuff, and if you go into Thingiverse, for God's sake, join up. It's, yeah, like you can build experimental quadruped robots. I've seen that. That's my second robot that I'm going to build. I'm currently I'll most probably build this one before I finish building the big one. But I'm building a life-size 3D printed robot. It's called the InMove robot, but I'm still learning the Arduino. I'm still learning everything. But it's still pretty basic. But there is the software out there that you can get, and the code, they've got the code, you can get they give you links to the codings. You can build robot arms, you can build robots that write for you, you can build toys for your kids and things like that. So if you want to get into something that's a bit more than nothing, just take some tips from a plastics manufacturer. Be careful of the filaments you buy, be very choosy of what filaments you buy, find out their process, you don't want water bath filament because they just make it too hot, so they've got to water bath it, and it sort of, and then you're using a rehydrated plastic, which is not good. But there's so many different things out there that you can actually use 3D printers for, and it's not just printing those models. See, everybody see those videos and all those funny little models up behind the guys' heads and things like that, because they're benchmarking. They're like all about because they just want to get a lot of free 3D printers. I do reviews, I do a review, and I don't care if I send the bloody thing back to them. It's sort of, to me, if I review something, I'm reviewing it for a thing. Like that printer I'm printing on now, I wouldn't refer it to a single soul. Unfortunately, I bought that one and I was ripped off and got sent a second-hand one. And I've had to do very major modifications to that printer that I'm printing on at the moment just to get it running, and it's cost about half as much as I paid for it to get it into a working state. And it prints reasonable, like for little things and stuff like that. It even printed those side panels for the CNC machine, but they're a bit wonky, but that's not going to matter. They're still solid, and that's the good thing about it. And everybody thinks that CNCs are like, not CNCs, 3D printers are print objects are very weak. I'm going to show you how strong a 3D printed object is, and I'm going to put a lot of force into this, and I mean I'm putting a lot of, now that's the little item there. That's by the way, I forgot that. You can see that stuff there. That was a crap. That's from a water bathed filament. I was testing some filaments, and that's a water bath filament, and that's the type of filament that you get. But it still welds together. It's just really shitty when it's glued, when it glues itself together. But it's welding, and it came good after a while. But I swapped plastic about halfway through, went to a plastic I knew, and it was still in there for a couple of layers, and I just abandoned the print after that. But it's still strong. Like, I'm putting shitloads of force into that, and I mean I'm putting shitloads of force into it. And I can't break it. So 3D printing, folks, yeah, objects are very strong. Oh, by the way, that has been water bathed. Even before I did that test, I definitely water bathed it. Because see, what a lot of people don't realise, it prints in a crosshatch pattern. One layer, it will crosshatch in one direction, it will crosshatch in the opposite direction on the next, so on and so. So what that does, that actually strengthens the plastic. So don't worry about 3D printing parts that you need, or rapid prototypes. They are pretty strong. They won't do certain things, and they are more prone to breakage because their strength is not going to be as good as an injection molded, but sometimes they're stronger than injection molded because there's like tendons in the thing, and that's the way I look at it, if they're using tendons. And like, I've actually put a bit of strength in it. I actually did put a bit of a bend in that, but it still didn't break. And even though that was made from a shitty piece of PLA, only had a 5 metre length of it, and yeah, printed it, and it just came out so wonky. And I knew straight up, as soon as I saw the problems with it, I just thought, I kept on thinking, oh, I'd let it go. And this was the first attempt. That was the first attempt of a water bath PLA. So that's how you can tell a shitty plastic. That had plastic explosion in it. It didn't adhere properly. It's blistered. There's blisters everywhere in it, and those blisters are actually caused by the hydration of the plastic. This is why when you 3D print, you only 3D print with good quality PLA or ABS. Unfortunately, as I showed you in that other video, that some companies do, oh, sorry, I haven't put that up yet, but some companies do water bath their PLA, and when you try and print with it, you get those results that I just showed you. So, and that is caused wholly and solely by bubbles of water steaming up inside the plastic while it's being thing. Because you've got to remember, if there's water in that plastic and it hasn't been dehydrated, that water is still in the plastic. Hence, that's why you get this as a result when you're printing it. So, and that's wholly and solely because of moisture in the filament. This is why water bathed filament, and I know Pursa, and I can say this openly, Pursa printers, when they make their filament, they water bath their filament. They use the same operation that I showed you in that other video, which will be up next. And so yeah, just watch that video when I get it up. Have a look at the photo. Actually, I've got the photo on the computer. I can show you right now. And because this is a company. He sent me, oh, this is our process. First thing I saw was water bath filament. You see, you've got the extruder all the way over there, then you've got 2 water baths, and then it comes through, then it starts rolling up and drying out. See, the reason they've got to roll it over those rollers is because that filament is still wet, because they've rehydrated the plastic. You should not rehydrate. Anything that you're going to use in a moulding, welding, or anything like that should not be rehydrated. It should be dehydrated. And all they're doing is letting it dry so there's no water on it. And so you don't know that you get shitty plastic. But as I said, if you get shitty plastic that prints out like this, that is a water bath, because the water in it boiled and it causes that result. So when you're printing and you start to see plastic going like that, I'll tell you straight up, you've got a water bath PLA or a water bath ABS. See, the only time you water bath something is after you've done something like I'm doing. I'm making the finished project. Yes, the PLA or ABS, whatever you're using, must be rehydrated once you've made your final project. Filament is not final. It's not a final project. You can always tell the difference between a good factory of filament and a bad factory. A good factory will build towers, and their injection molding machine is pointing down, and they drop it. And it doesn't stretch or anything like that, because when they're pushing it out, they're using a lot more pressure, and it's a slower process. These guys are pumping it out fast and cheap. So when you go to a factory like this, and you buy filament from a factory like this, you are buying fast and cheap Chinese filament that's made using because that size extruder is not even really, you couldn't even really call that an extruder, trust me. I've got one of these machines, and it's like, I would say it's about the size of the extruder and the first water bath, and it's about as high as it is to the top of that dryer here. So from the ground there to about there, and let's just say my extruder is taller than me. When you put the hopper dryer on it, you need a ladder to turn the conveyor from the hopper dryer, from the storage into the hopper dryer. You need a ladder to get up and move the conveyor. It's that high. That is a very little cheap Chinese version of extruder. Anybody using these types of extruders, they're water bathing it, and you're going to get those print results that I just showed you. So be very careful. It's something that a lot of people don't know. And I've come across so many guys that are in the 3D printing business, and they say to me straight, oh no, I know what I'm doing. I've been doing this for 10 years, mate. I've been doing it for 10 years. what do you know about plastic? Oh, well, I go buy my PLA and I put it in here and I put it in there, and they know nothing. It's the blind leading the blind. So many of the channels out there that do 3D printing channels, they've never studied plastic. They've never been in the injection molding industry, or they've never been plastic welding industry. See, I was in both. I was in injection molding. I started out plastic welding, and then I invented something whilst I was studying, and pretty much worked up a brilliant invention. And the thing is, it had to be injection molded, so I had to go and learn a different type of use of plastic. But see, with plastic welding, it's very similar to 3D printing, because you're using a higher temp. You're melting beyond pretty much melting beyond the thing. You're making a molten liquid PLA, where with extrusion, it's not exactly molten. It is molten to a certain extent, but it's not as boiling hot as what it is coming out of a print head. By the time it goes into an injection molded die, that's already cooled down, and it uses a lot of pressure to push it in, and it's the pressure of it that actually melts it to the right temperature. You do have to sometimes make it hotter, but I watched a Chinese video on on plastic extrusion, and they're like pushing out, what was it, 9 or 10 filaments at once, and I think it was wood filament. So that wood filament is going to suck up twice the amount of bloody thing. This is why a lot of people have trouble with filaments. They say, oh yeah, well, I bought a filament and it's real shit. It's crap. The reason is because it's been water bathed. This type of extrusion filament is bad, and it really is. Anything that's water bathed is bad. Because I'll give you an example. I'm actually currently knitting the two pieces of that I've just pulled apart from the thing, and that's the way it formed naturally. It just did it. And as soon as I did that, because after I did the first print, it came away from the board, I discovered what was happening, and then I thought, well, okay. And I didn't realise I totally spun out and forgot to actually swap the PLA over, and halfway through the print, and you can see where I've actually swapped over the PLA in it, and like it goes from a real shitty PLA to a real good PLA. I'm going to use this with my customers so I can physically show them the difference between a good PLA and a bad PLA, and because as soon as I swapped the filament over, it came good. But having a water bath filament, that water is still in it when you're using it, and this is why you get those weird effects in your PLA. Having it too hot, having it 220, will make those effects even more pronounced. You would have to lower your temp, and I think this is why a lot of people lower their temps down, because they're using shit filament, and that's why their plastics don't stay together as strong. And I'm still playing with, I've been bending this thing something shocking, and I'm gonna, like when I do a stream later, I'm actually going to be bending it in front of everybody and showing them what and how strong it is, because it is really, really strong. Even though some of it was made with shit PLA, the thing is I use the right temperature to weld it, and that's what plastic printing is. It's welding one plastic to a cooler plastic, and you're using the hot, and it's exactly like welding when you're welding with a welder. You've got to get that one up hotter than the other one to make the thing. One's got to be hot, that's why you've got a hot bed, and it keeps it up to about 50 to 70 degrees, whatever you want. Certain plastics will require a lower heat bed, some will require a hotter heat bed. But the problem is there's so many guys out there, and they're all 3D geniuses, but it's the blind leading the blind. They've been taught from somebody that's been in 3D since it came out. But see, when it came out, these are unexperienced people that learnt. They taught somebody else, and they taught somebody else, and they taught somebody else. So you've got people that, there's a good example to it. You've got 6 blind men, right? You've got 6 blind men, and they want to know what an elephant is. So they all grab part of the elephant and feel the elephant and everything. One grabs the trunk, feels the trunk. Another grabs the leg, feels the leg. Another grabs the tail, feels the tail. Another grabs the ear, feels the ear. And yeah, it's sort of like one says, oh well, I describe the elephants very much like a snake. That's the guy that done the trunk. And the tail. Sorry, the tail. The tail. It's very like a snake, a small snake. Then the trunk it's very much like a python. And the guy that touched the leg, they're as big as a tree trunk. It's sort of, and then the guy that touched the ear, very much like a leaf. And this is what it's like in the 3D world at the moment, because so many of these guys out there. Do you know that there's it's only in the recent years that guys like me that have been in injection moulding and plastic welding industry are only now seeing the benefit of these, because we used to pay people to print them up for us because we didn't want to outlay, because back then some printers were worth like, $6,000, and it was a big outlay to print something small, and we didn't want to go through the hassle and everything. We didn't know that much about them, and there were a lot of problems with 3D printers. They were in very beginning stages. They're only now starting to come into a commercial stage to where everybody's getting it. Like, I'm still making 3D printers because I've been into making shit for years. It's taken me 2 years to build the K8200 because what's been going on. But the point is, with it is truly the blind leading the blind. Now, if you noticed, that print's finished, but I'm leaving it there for a couple of seconds, because if I don't leave it there for a couple of seconds, right, I want that heat bed to go down to, got to get it to the right temp. I want that heat bed to go to the right temperature. So I wanted about half of what it is before I attempt to move the plastic, because at the moment it's about 50 to 70 degrees, so I've got to bring it down. And once it's down, then I can remove them, but I've still got to be careful of bendage, because I know that I've got a really good hotbed, and the PLA that I'm using at the moment is a very good conductive PLA, because there's no water in this one. And it's sort of like it's almost identical in colour to the one that I just used, the crap one. But I know this is the one I'm back to using, the Cocoon Create one, but the other one was from, I can't remember who that mob was that sent me that roll of PLA, but I won't be buying their PLA, it's crap. And the whole thing is, it's sort of, when you're buying your PLA, be careful of what you buy. You've got to know the buyer that you're buying it from, and by doing this it's a lot better, because so many people just jump on YouTube and they go out to YouTube and they buy some thing. There is actually a problem. There currently is a major problem with YouTube talking about that. Not YouTube, no, YouTube. With eBay. I'll show you it actually. Show you the drama with eBay. Alright, we'll go there. And we'll search for filament. But this is happening all over. It's a joke. eBay needs to actually do something about this. Sort of, actually here, okay, that one's fixed, that one's, yeah, okay, here. We've got a filament there saying 16 to 1695, you've got others to say 1995. But you know, no matter what you do, you click on that, there, you click on that, you go to a different one. Is any of them? No, none of them are, and I've already done this, by the way, none of them are that 1695. So yeah, you've got to be careful when you're buying them and stuff like that. It's sort of okay, now this guy's, okay, by the way, this guy's PLA, I've just bought some and I've got to try this yet. But the brand is what I was trying. I was trying the brand rather than the thing, because I'm looking at actually purchasing a reasonably large amount of PLA, so I wanted to test it. I found out this seller actually sold PLA, but unfortunately he advertises one price and you get you don't get the right price. You've got oh, okay, he does have one product at 16. Wow, okay, he's got one product at 69.95. But instead of like never trust the prices when you're buying from things, because there's so many different things. And you want to know the ironic thing with colour. It's the same bloody price as white and black. There's no difference in price. In the manufacturing cost, there's no difference, but they tell you, oh, there's a major cost difference. And so now they're safe to pull off the board. It's still hot, but like, I'm more worried about burning my hand at the moment than anything. Always make sure you get those little tiny filaments off the thing. So I'm just going to test this, make sure it goes together, and hopefully this time I got it right. And so something is wrong. So yeah, it's sort of yeah, it's got a slight problem. Something is wrong on it. It's sort of, I don't know what. Yeah, let's see what's wrong. There's a little, I've left something in there that's not allowing it, but it will fit. You've got to go through all these things when you're doing it. Sometimes you've got to file bits off. It's on your test piece, so it tells me I need to go back into Tinkercad, and you'll most probably notice I haven't shut Tinkercad down. And I haven't shut it down because of this exact problem that I've just got, where it won't fit because something is not exactly right. So it's just little bits of trimming here and there, and so you go through and just discovered what it is. Just discovered what it is. A couple of little notches, because I have modified this, a couple of little modifiers, pieces that should have actually been removed that I didn't remove. So while it's still hot, I can actually pull them off. So now when I push it on, it should go on, and I'll show you the end result once I get it on. Yeah, there's a couple of little clips. So that's the finish unit assembled. So there it has, you've got the basis for the, oh sorry, you can't even see it. Sorry about that, folks. But I forgot to remove a couple of little notches. Where are they? I'll show you the notches that I forgot to remove. I've got to find the bloody, what screen is the mouse on? I've got the mouse at some screen, I can't bloody find it. That notch there, I had to just had to remove that notch there, and that notch there. So after removing those two little notches, fits together, so I'll remove them now that I know that that's all that's got to be done for that to fit together, but it fits together nicely. Your filament goes through, and sorry, I don't have the camera set up on the other thing at the moment. So the filament goes through there like that. It attaches via that point or via those 2 points, or you're going to attach them via that point, whichever one you like, depending on how you've got it set up. You might want it to set up in one way, and then as the filament runs out, it turns the piezo alarm on, and you know that you've got about 2 minutes to rush over and start feeding new filament through. So yeah, there's little things that you can do and things like that. So but I'm just going to show you the piece, because I just realised I didn't show you the component. But there's the component there after I remove those two little notches. So not only is it got the switch, it's actually got a spot to put the piezo alarm, and it's got the speaker holes in it. So there you go. And that was the CNC piece that I'd forgotten to remove the picture from the screen that I made for the side of the CNC. So yeah, there's a lot you can build with a 3D printer. It's not just for building little toys, folks. It's for actually printing stuff that is actually very useful. So what I'm going to do now is I'm going to end this and say thank you very much for all joining me for this video. And yeah, I'll get that other video up in a couple of hours. So thanks very much for joining me, and to see you all later. This video was proudly brought to you by whatisZS.com. ZS is coming soon. ZS apologises. Currently our website is down. The problem is being attended by the monkeys, and once we sort out the drama, we will get it up and running. Thank you very much. And yeah, we will put a link to the site though, so you can go and see it and take it from there. So anyhow, thank you very much. And by the way, ZS is one of my inventions. Thank you.